Hello everyone, my name is Rohit Singhal and we were discussing about the redox reactions. In the previous classes I have started with the thing oxidation number. I have told that oxidation number why we need it, we need it for to see the electron transfer in the covalent compounds. What oxidation number assumes is oxidation number assumes a complete electron transfer from a less electronegative element to a more electronegative element. For example, I have taken the case of LHA, HCl, H2 I have taken. So, oxygen is more electronegative. So, we know that there has been a sharing of electrons between hydrogen and oxygen in HUL, that is why it forms a covalent bond. But just to calculate the oxidation state or oxidation number, what we assumes to a complete electron transfer from a hydrogen to oxygen. So, hydrogen get a +1 and oxygen get -2. Now, to calculate the oxidation number for various elements in various compounds, there have been assigned a certain rules. First rule we have discussed, that first one was what? The rules we were talking about to calculate the oxidation state. The first rule we discussed it in an element in free or uncombined state, element present in free or uncombined state, the oxidation number is 0. For example, H2, Cl2, sodium, magnesium, okay. All those have oxidation number of 0. Why is it so? You can say that hydrogen is combined with another hydrogen. It is because both the elements have same electronegativity. Both the atoms have same electronegativity. Okay. And what oxidation number tells us? Complete electron transfer from less electronegative to more electronegative, right. And the electronegativity of both the hydrogens, because element is same na, so electronegativity is also same for both the hydrogens. So, there is no complete transfer, or we can't assume any electron transfer from one to another. So, we assume this hydrogens chlorine in the present in free or an uncombined state, the elements are present in oxidation number 0. Second rule we have discussed for ions. For ions I have said oxidation number is equal to the charge on the ion. Oxidation number is equal to the charge on an ion. For example, Na plus, Mg2 plus, Al3 plus, Cl minus, the oxidation number is +1, +2. Oxidation number for aluminium 3 plus, charge is +3, oxidation number is +3. For chlorine minus, oxidation number is -1, so as the charge is -1. Okay. So, these two rules we have discussed till now. For the elements present in free or uncombined state, oxidation number is 0. For the second ions, oxidation number is same as the charge on the ion. The third one is I am specifically discussing the case of oxygen. Okay. What happens is oxygen normally presents is, or let us say generally, generally presents in -2 oxidation state, -2 oxidation number. Okay. The general oxidation state of oxygen is -2, and this -2 means oxygen carrying a -2 charge, this we call as oxide. What we call it as? Oxide. You have seen that this MgO, Mg carrying a +2 charge, O carrying a -2 charge, it is called magnesium oxide, right. CaO, calcium oxide. Okay. So, the oxygen normally have a charge of -2 and it is generally present in -2 oxidation number, because you know in general oxygen needs 2 electrons to fulfill its octet, right. So, it is in general it is present in -2 oxidation number, that is called oxide. However, there are two other states of oxygen that is possible. One is O minus, let us say it is not O minus, it is actually O2 minus. Okay. These two are the other things, other states possible for the oxygen. One oxygen carrying -2 charge is called oxide. One oxygen atom having minus 2. Okay. Now, for O2 2 minus, O2 2 minus is what? 2 oxygens are carrying minus 2 charge. That means one oxygen carrying how many charge? One oxygen carrying minus 1 charge. Okay. 2 oxygen combinedly are carrying the minus 2 charge. In case of oxide, only one oxygen atom carrying the minus 2 charge, whereas this O2 2 minus, 2 oxygens combined getting minus 2 charge. That means one oxygen having a 1 minus charge, and this state of O2 2 minus, this state of oxygen, what we call it as? We call it as peroxide. Peroxide. Example I will give you. Example, let us say Na2O2. Okay. This is called as sodium peroxide. Sodium is present in +1 oxidation state. I have told you that the group 1 elements are present in always in oxidation number 1. That means 2 sodium having 2 plus charge. That means here 2 oxygen are carrying what charge? 2 minus charge, and if 2 oxygens are carrying 2 minus charge, that means it is a peroxide. Okay. The other one is O2 minus. Now, what it seems similar, it is not O2 minus, it is O2 and charge is minus 1. That means 2 oxygen carrying 1 negative charge. Okay. 2 oxygen atoms are carrying 1 negative charge. That means 1 oxygen atom, charge on 1 oxygen atom will be minus 1 by 2, right. If 2 oxygen are carrying a charge of minus 1, so 1 oxygen will carrying a charge of minus 1 by 2, right. So, 1 oxygen atom has a charge of minus 1 by 2. This type of species we call as superoxide. What we call it as? Superoxide. Example, there are some examples. Let us see an example of KO2. Okay. We know potassium is +1, that means this O2 has a charge of minus 1, means 2 oxygen are carrying a minus 1 charge, and this species is called what? This species is called potassium superoxide. Okay. The oxygen we have discussed, oxygen can exist in generally exist in minus 2 oxidation number. This minus 2 oxidation number when present in this O2 minus, it is known as oxide. So, any element when it combines with O2 minus, let us say Na2O, let us say MgO is called magnesium oxide, CaO calcium oxide. If it is combined with Li what 2O, this is called lithium oxide. Okay. But oxygen can have 2 other oxidation states also possible. What is that? In case of oxide, 1 oxygen carrying a 2 minus charge. It is possible that 2 oxygen atoms combinedly carrying a charge of minus 2. That means it will have a 2 oxygen atoms having a charge of minus 2, 1 oxygen carrying a minus 1 charge, and this species is called peroxide. For example, Na2O2, this is known as sodium peroxide. The third case is O2 minus. Oxide, 1 oxygen carrying 2 minus charge, peroxide, 2 oxygen carrying 2 minus charge, superoxide, that is 2 oxygens carrying a charge of minus 1. That means total charge on 1 oxygen atom will be minus 1 by 2, and these type of species are called superoxide. One of the examples of this species is KO2, potassium superoxide. Okay. Now, you have till now seen that oxygen is having a minus oxidation state. Now, we will see, or one wonder that is it possible that oxygen also carries a positive oxidation state or positive oxidation number, because one thing this keep in mind, one element can have a various oxidation states or various oxidation number depending on which element it is combined with. Okay, just keep this thing in note that one element can be present in various oxidation numbers depending with which it is combined with. That means, one element can have a various oxidation numbers. Okay. It can have +1, 3, 5, 7 depending on what the other element is, whether the other element is positive, more electronegative, less electronegative, okay, whether the element is having a what charge, let us say oxygen is having a -2 charge. Okay. These things we will keep in mind that one element can have a various oxidation state numbers depending on the various compounds. Now, I have discussed about the only the negative oxidation numbers of oxygen. Let us discuss whether the oxidation number of oxygen is can be positive or not. So, can oxygen have a positive oxidation number? Okay. Now, tell me this thing, oxygen, to have oxygen a positive oxidation number, what we need? To have oxygen in positive oxidation number, what we need? We need a more okay. What we need to have oxygen in positive oxidation number, what we need? We need a more electronegative atom than oxygen. We need an atom that is even more electronegative than oxygen. Which element it is? Element is fluorine. Fluorine is more electronegative. Fluorine is more electronegative than oxygen, and it forms a bond. It forms molecules with oxygen fluorine. One is OF2, O2F2. Okay. This is called oxygen difluoride. Oxygen difluoride, and this is called dioxygen, because two oxygens are there and two fluoride. So, difluoride. Okay. So, now you must wonder what the oxidation state of oxygen is. We know fluorine is present in what? Fluorine is in -1 oxidation, -1 oxidation. Okay. So, for two fluorines, what is the total charge? -2. That means, oxygen will have a oxidation number of what? +2. Here, one fluorine having a -1, two fluorine have a -2. That means, two oxygen will have a +2 charge, but it means one oxygen will have a +1. So, if someone asks that oxidation number of oxygen is, in this case it is +1. Okay. So, it is possible to have oxygen also in positive oxidation state. When it is possible? It is possible when we combine oxygen with even more electronegative element, that is fluorine. We have the such molecules in the nature, that is OF2 we can and O2F2, oxygen fluoride difluoride and dioxygen difluoride. In one it is present in +2 oxidation state, in another it is present in +1 oxidation state. Okay. Now, further I have discussed as oxygen. Now, we will discuss about the hydrogen. Okay. Hydrogen we know only has one electron. So, it can the only possible oxidation state of hydrogen is either +1 or -1. 0 it can be possible, 0 in free or in 0 when the oxidation state of hydrogen is 0, for example H2, oxidation state is 0. So, the two other possibilities of the oxidation number of hydrogens is +1 or -1. Now, when it will be plus 1? You know plus 1 when combined with more electronegative element, right, or combined with electropositive element, or say less electronegative element. Right, these two are the possibilities, plus 1 and minus 1. We know what are the more electronegative elements, that is non metals. Non metals are more electronegative, and what are the electropositive elements? Metals. That means, when hydrogen is combined with metals, for example, NaH, KH, MgH2, any of this case, this hydrogen is present in -1 oxidation number, whereas when it is combined with non metals, for example, oxygen, sulfur, halides, okay, this is present in oxidation number is +1, H plus Cl minus, H plus O2 minus, H plus S2 minus, H plus F minus. For metals, Na plus H minus, K plus H minus, Mgh2, Mg2 plus H2 minus. Okay. CH4, it's not, carbon is not metal, it's non metal, but carbon is more electropositive. In general, mostly the electropositive elements are metals. Okay. CH4 also hydrogen is -1, because carbon is less electronegative than hydrogen. Okay. So, this is for the hydrogens. Okay. I am giving you a just hint. What happens in mostly cases, normally what is the criteria of us to write any compound is what we first write atom with positive charge. Whenever write any formula na, what we write is first an electropositive element, or let us say atom with positive charge, and then we write atom with negative charge. Okay. So, in case of hydrogen you can use this trick. Okay. For example, H2 I am written, that means hydrogen is on the left side, means it is carrying a positive charge, that means it have a oxidation number of +1. Okay. While in case of NaH, KH, I have written on the right hand side, it means it is carrying a minus charge, that is the oxidation number of hydrogen is -1. You can just keep thing in mind, this is a accepted rule, or this is mostly everyone follows, that all the any compound, any molecule, we write the formula of it, we write first the atom carrying a positive charge, then we write an atom with a negative charge. So, for hydrogen it is very easy for you to determine whether it is in +1 or -1 oxidation state just by looking the formula. If it is present in right hand side, it is -1, present on the left hand side, it is +1. Okay. So, this is just the trick. Okay. This is just the trick, or you can just for the shortcut you say. Okay. Mainly you have to focus on this thing, these are the reasons. Okay. So, this is for the hydrogens, whether hydrogen is present in +1, -1 or 0. In today's class I have mainly discussed about the oxygen and hydrogen, because these two are the atoms that are mainly used, or it has been widely used in any formula, compound, or to or because you will be coming across this oxygen hydrogen most of the times while calculating the oxidation number. So, that is why I have dealt with this oxygen and hydrogen separately. There have been 1 or 2 rules left that we will discuss in the next classes, and then we will discuss about the types of redox reactions. Thank you so much.